Today we are going to look at the formation of ethyne molecule. Is right? Formation of ethyne molecule. Now, ethyne, as we know, we have two carbon atoms which are triply bonded, and each carbon atom has one hydrogen. Each carbon atom has one hydrogen atom. Okay. Now, that's why what we can write here, each of these carbon, it is having two sigma bonds. That means it will have sp hybridization, and this will also have sp hybridization if we talk about the steric number. The steric number in this case will be equal to 2, and that is why the hybridization will be equal to sp hybridization. Now, when we write sp hybridization, then I will start with the excited state. Excited state of the carbon atom. Those who were present yesterday, they can easily understand that we will have something like this. One electron in each of these orbitals. Okay, so when you have ground state, then in that case you have 2p2, but in excited state there will be excitation of one of the electrons from s orbital to the p orbital, and this is another carbon atom. We have two carbon atoms. These are the excited state of those carbon atoms. Now we need sp hybridization, so I will take one of the s orbital and the other will be the p orbital. Two atomic orbitals from here, and here also I will take the two atomic orbitals s and p like this. Now when I hybridize them, then first of all there will be some p orbital which will be as it is. P orbital as it is. Then after that we'll be having the sp hybrid orbital. Now sp hybrid orbital will also have two, so there will be one sp and the other is two sp hybrid orbitals, and here also you have two sp hybrid orbitals. Now these are pure p, and this is hybrid orbitals. Okay. Now each carbon atom is attached with one hydrogen. So here is your one hydrogen, one s orbital, and both of these will be bonded together. Here we have another hydrogen orbital, 1s, this will be bonded together. There will be a bond between sp of one carbon and sp of the other carbon atom. After that, there will be a pi bond. There will be a pi bond between, I can say, these two. Right? And there will be a pi bond between these two. Okay. So there will be, this is sigma. All the hybrid orbitals, this is sigma. This is sigma. This is also sigma. This one is pi, and this is also pi. Okay. Now, if you want to see the complete picture of ethyne molecule, then it will be something like this. Please see here. I'm writing the carbon, and this carbon will be having two hybrid orbitals. So I will write the hybrid orbital like this. This is one of the p orbitals, sorry, one of the sp orbitals. And this is another sp orbital. Okay. Now, similarly, we have another carbon atom, and that carbon atom also have two different sp hybrid orbitals. Okay. So for sp, I will be another carbon atom, and they will be overlapping like this. Now, since all of these are sp, I will give it one color. Suppose it is blue, right? Giving the carbons white color here and also white color here. Okay. Now these are what? These are the sp hybrid orbitals. So as you can see, carbon and carbon, sp and sp is making one bond. So there will be a bond here. And here you will have two electrons. Similarly, each carbon atom, it is bonded with one hydrogen atom. Each carbon atom is bonded with one hydrogen atom. So I will make this hydrogen atom also as blue. And here also there will be overlapping of orbitals. And there will be a bond here with 2 electrons, bond here with 2 electrons. Okay. After that, we have 2 pure p orbitals. We have 2 pure p orbitals. In order to make pure p orbitals, I have to draw something like this. Okay, so this is one p orbital, and this p will be interacting with each other like this. And then there will be another p orbital. I'm making it with green. Okay, and the green one will be interacting with the green one like this. Okay, so now here how many bonds we have? We have carbon and carbon. White. Carbon and carbon. Between them, we have a sigma bond, which is blue in color, right? The blue orbitals are taking part in the sigma bond. Then we have a red, and then we have one green, and then we have for hydrogens also. All of you got this? Yes or no? Please tell me. The ethyne molecule.
Yes, sir.
Anji बताएं, right? Okay. Now please write here the shape is linear, and then bond angle 180 degree.
Okay, you should. Before part.
Anyone still writing? Anyone still writing? Yes or no?
Yeah, yes, sir.
Okay, okay. Please write. Let me know once you're done, guys. Anyone still writing? Anyone still writing? No. We have seen that in ethane, I have CH3 simply bonded with CH3. So this was sp3 hybridized. Both of the carbon atoms were sp3. When we had CH2, double bond CH2, then this was sp2. Then when we had CH, triple bond CH, then this was sp. So from here, I can understand something. Please see here. If I talk about in terms of pi bond, or rather I should type first of all about sigma bond and pi bond, and then I will talk about single bond, double bond, and triple bond. Okay, and then we will talk about the hybridization of carbon. Okay, so please see here very carefully, and you have to remake this particular table once you are at home, so you will have an understanding what is happening everywhere. Okay, so let us suppose if we have 4 sigma and carbon can make only 4 bonds, so there will be 0 pi. And how many single bonds? Because sigma is single, so there will be 4 single bonds and 0 double bond and 0 triple bond. That means if we have only single bonds, then the hybridization of carbon is sp3, as was the case of ethane molecule. Now let us reduce the number of sigma bonds by 1. So I have 3 sigma bond and I have 1 pi bond. I have 3 sigma bond and 1 pi bond. Now in this case, you will have, please listen very carefully here. You will be having 2 single bonds and there will be 1 double bond. Okay. Sir. How 4, sir? 2 plus 1 to 3 ho jayega? No. Bacha, please listen. Double bond means there are 2 bonds, na? So 1 mein 2 bonds ho jayenge, right? So there will be 2 plus 2, 4. Total 4 bonds will be there. All of you got this? Yes or no? Please tell me. Sara, Siddika, Yasir, Alia, right? So, and in this case, we have 0 triple bonds, right? 0 triple bonds, and in this we'll be having sp2 hybridized. Let us reduce it furthermore. I have 2 sigma and I have 2 pi bonds. I have 2 sigma and I have 2 pi bonds. Now, in this case, you will be having how many single bonds? 2 sigma. So obviously there will be how many sigma bonds? 2 plus 2 will be 4, right? So here you will be having, there will be 1 single bond and there will be 0 double bonds and there will be 1 triple bond. Still, you can see 1 single bond, 1 bond. 1 triple bond, that means 3 bonds. So 3 plus 1 will be equal to 4. Now, in this case, you will be having sp hybridized. You will be having sp hybridized. Now, there is another case in which you can have 2 sigma and you can have 2 pi. And that case is when you are going to have only 2 double bonds, right? This is 0 single bond and 0 double bond. So 2 2s are 4. We still have how many bonds? 4 bonds, right? In this case also, you will be having sp. All of you got this in terms of both pi, sigma, single, double, and triple? Yes or no? Please tell me. So I am writing single, double, and triple also because you will not be always counting sigma and pi. So when you see here, for example, this carbon atom has only single bond. There is no double bond here. sp3. Here we have 1 double bond, so sp2. 1 double bond, sp2. Here we have 1 triple bond, so sp. So you just need to look at the double and the single bonds. If there is only single, then sp3. If there is 1 double, then sp2. If there is 1 triple, then sp. If there is 2 double, there will be sp. Okay. So you just need to look at double and triple bonds in order to understand about the hybridization of carbon atoms. Please write this down. समझ के लिखिएगा, please, all of you guys, है ना? Understand it and then write it. Let me know once I can move on. Done? Okay. Write a question. Determine the hybridization. Of following, or rather I should write of each carbon atom in following, of each carbon atom number 1, please see. You have CH3, single bond CH, double bond CH, single bond carbon, and triple bond CH. ठीक है, ध्यान से जरा देख लीजिए यहाँ पे. We have how many carbon atoms? We have 1, 2, 3, 4, and 5. Now the first carbon atom, how many double bond? Is there any double or triple bond for the first carbon atom? Tell me, guys. Any double or triple bond for the first carbon atom? Yes or no? Any double or triple? Anji. First carbon atom. Any double or triple bonds? Alia, Yasir, Sara, Siddiqa, Martin, tell me.
Yeah, there is none.
First carbon atom, I'm saying. First carbon atom.
Oh, no,
No, sir.
there is no.
First carbon atom. I'm talking. What about this? Alia, Sara, Siddiqa, tell me. First carbon atom. Any double bond?
No, sir.
So the hybridization will be. If you have no double or triple bond, please look at the chart. Look at the table.
SP3.
All of you got this? See, 0 double and 0 triple. It is sp3. What about the second carbon atom? Is there any double or triple bonds?
Double bond.
Double bond. How many double bonds?
1.
One double bond, right? So it will be, look at the chart,
SP2.
one double bond, sp2. Similarly, the third carbon atom will also be
SP3.
sp2, no? Because it is also
Sorry,
a double
sorry.
bond, right?
Yeah.
What about the fourth carbon atom? Any double or triple bonds?
Triple bond.
So it will be
SP.
sp. What about the fifth one? What about the fifth one?
SP.
sp. Okay, so this is how you have to do it. Please write 2 more questions. Take 5 minutes for this. Someone has sent me an answer.
Yeah, very good. It's correct, Alia. Others, please send your answer, whatever you have done.
Sir, in WhatsApp.
Yeah, what's
Sarah has sent. Second का second वाला देखिए, second carbon of second one. Sarah. Also third carbon second. Third question second carbon.
Yes, sir.
You don't see any mistake. See here, guys. Those who have not sent. First carbon, second carbon, third carbon, fourth carbon. है ना? Here we have 4 carbon atoms. Now this is not having any. This is not having any double bonds or triple bonds, right? So this will be sp3. What about this one, Sarah? Any double or triple bond? Sarah?
No, sir.
So it will be sp3 now.
Yeah.
This is having triple bonds. This will be sp. This is having triple bonds. This will be sp. Now look at this one. This is having a double bond, so it will be sp2. Now what about this one? How many double bond does it? This one has. How many double bonds? 2 double
2.
bonds. Look at the chart. 2 double bonds. Look at the chart. What will be the hybridization?
SP.
sp. And what about this one? sp2, right?
Mm.
Now all of these are carbon atoms. Okay, so maybe you have not seen the structure before. All of these are carbon atoms. Fine. In carbon, you can see this is one double bond, right? It will be sp2. Here also a double bond, sp2. Here also a double bond, sp2, 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 and this is also sp2. All of you got this? Yes or no? Please tell me.
Yes, sir.
Please write this down quickly. And after that, we'll write few remarks point. Anyone still writing? Anyone still writing? Now, please look at remarks, and we'll still talk about the hybridization of carbon atoms, because we have to study carbon and its compound. I mean, not carbon and its compound, that was in 10th standard, but rather you have to study hydrocarbons in this class. And then we have a complete part 2 of chemistry, that is organic chemistry, completely related to organic chemistry, carbon and compounds. So hybridization. And I will talk about the percentage S character and the percentage P character. Okay. Percentage S character and percentage P character. You will understand what I'm trying to say here. Okay, don't worry. Hybridization sp3. Or rather, I should start with sp. Let's start with sp. So sp, in this we will be having 50% S character and 50% P character, because there are only 2 orbitals which are mixing. How many orbitals are mixing? 2 orbitals. One is S and the other is P. So the outcome will be 50-50. They will be having 50% S character and 50% will be P character. When I have sp2, then I am using one s orbital and there are two p orbitals, right? There are two orbitals which are of p subshell. So in this case, we'll be having 33.33% of s and 66.66% of p character because we have more p. In the case of sp3, I will be having 25% s and 75% p. Is that clear? Yes or no? Please tell me.
Yes.
Okay. Now please listen very carefully. Since s orbital is spherical and nearer to nucleus, it will experience greater pull from nucleus. It will experience greater pull from nucleus. That is why, therefore, higher the percentage S character, higher is electronegativity. Because if we are having a sp hybridized carbon, sp hybridized carbon will make a bond with sp hybrid orbital, and the sp hybrid orbital will be nearer to the nucleus. That is why, though that particular hybrid orbital is going to, whatever is present there, it is being pulled by the nucleus more effectively. Therefore, if I talk about electronegativity of different types of carbon atom, this is an important result that you have to memorize. Okay, to understand it very properly, the statement, and then memorize this particular conclusion: electronegativity. Electronegativity is highest if you have carbon which is sp hybridized, followed by carbon which is sp2 hybridized, followed by carbon which is sp3 hybridized. Is this clear? All of you understood this part? Yes or no? Please tell me.
Yes, sir.
Write this down. Then we are going to quickly look at steric number 5 and steric number 6. Okay. Eighth class it takes. Chemical bonding, it takes almost 8 class always. At least 2 classes there will be for introduction and this part. What I will say. Introduction, Lewis dot structure, formal charge. That will take almost like 2 classes. Then 2 classes is for valence bond theory.
Done,
2
sir.
classes for hybridization VSPER. Done, guys. All of you done?
Yes, sir.
No, sir.
No. Okay, jaldi लिखिए फिर no. Let me know once you're done, Martin. Okay.
Okay, sir.
Done, everyone? Is everyone done?
Yes, sir.
Martin, done?
Yeah, done, sir.
Okay, right next. So steric number 4 is completed. Steric number 4 was longest. We have to discuss many things there. And right next, steric number 5. Now, in steric number 5, we'll take the case 1, the first case. And in the first case, we will be having sigma bond will be equal to 5. We will be having 5 sigma bond. And we'll be having 0 lone pair electrons. 5 sigma and 0 lone pair electrons. Now, when we have 5, and so steric number is 5, so the hybridization will be sp3d. The hybridization is going to be sp3d. So the atomic orbital which are taking part in mixing is, we have s plus p plus another p plus another p. I mean, this p are px, py, and pz. Plus we will be taking the d orbital. Okay. Now, and when we are going to hybridize it, we will get 5 sp3d hybrid orbitals. sp3d hybrid orbitals. Now, when I am going to arrange it in 3D structure, when I'm going to arrange them in 3D, then I have to arrange them, see, in a kind of a spherical, as we know, in VSPER theory, we have seen that atom is spherical and the valence shell electron pairs, they will be on the surface of that particular sphere. And if you want to arrange it, it will be something like this. Please see. Let us suppose this is my circle. I mean, this is my sphere. And I hope you can, this is your equator of the sphere, okay? The middle part is equator. So in the middle of the middle part, you are going to keep the atom. Suppose here. And then if you want to, like, you can have radius, right? That will be the maximum distance. So I will start from here to here, maybe. And I will put another one somewhere here. Okay. So I have put 2 right now. I have to put how many more? I have to put 3 more. So I can put the another one somewhere like this. So this is also radius, right? I'm still on the radius. I'm still on what? I'm still on radius. Okay, please understand that. Now, this is also a radius, right? I'm going behind the plane. You can see I'm going behind the plane, and this is also radius, right, guys? Yes or no? Sarah,
Yes,
Martin, Saddika, Alia, no problem, right? Yes or no?
No, sir.
And similarly, this is also radius, right? Correct, guys? Yes or no? Please tell me. No problem till here.
No, sir.
This looks symmetrical, and they are far apart as, I mean, as far apart as they can. Okay. Now, this particular orientation, this is known as, if I am going to remove the sphere now, I will remove the sphere. So here are my I mean, you can say here are my electron domain, or you can say here are my electronic geometry. So I will shorten these things a bit so that it won't take so much space. I mean, we just need to see, huh? You know, don't need accurate picture. So this was the electronic geometry. Now, in this electronic geometry, if you see here, I can make a triangle using these which were in one plane only, right? All of these were in one plane. And then I can make a pyramid using this as the base, like this. There will be a pyramid above, and there can be a pyramid below also. Right, guys? So I can make, this is a structure which is known as triangular bipyramidal. So we have a triangular base, and there are 2 pyramids which we can make. So electronic geometry, it is known as triangular bipyramid. Electronic geometry, triangular, you'll write triangular, then bipyramidal. And the shape here will also be triangular bipyramidal. All of you understood this? Yes or no? Please tell me. And in short, we will write this TBP. Okay. Triangular bipyramidal. All of you understood this? Yes or no? Please tell me.
Yes, sir.
Okay. So this will be AB5. And maybe I will make some space for A. Here is your A. And you have B here, 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 and here. Right? Now, let us understand the trigonal bipyramidal structure a bit more, what I can say, a bit more nearly. If you look at these B bonds, there are two different bond angles that we can have. We did not talk about the bond angles till now. There are two different bond angles. If I talk about the wide bonds, can all of you see that? If I talk about only the wide bonds, then they are making 180 degree. If I talk about only the blue bonds, then the blue bond is making 120 degree. Yes or no? Correct, guys?
Yes, sir.
And if I talk about white and blue, then how much they are making? If I talk about white and blue, then obviously it is what? 90 degree? Yes or no?
Yes, sir.
White and blue, this is. So there are 3 bond angles here. There are how many bond angles here? 3 bond angles. All of you got this? Yes or no? Please tell me. Now, generally what we do, we ignore the 180 bond angle. Why? Because there will be no repulsion between these two. They are not even facing each other. They are facing oppositely. So there will be no repulsion. That is why we ignore the 180 bond length. Now, okay, if we ignore the 180 bond length, then what about the 90 and 20? Yeah, we consider those 90 and 20. And we have some specific name for that. For example, these wide bonds, which are kind of a straight line, these are known as axial bonds. This is known as axial. And all the 3 that we are having in blue, this is known as equatorial. These are known as equatorial bonds. Okay. So if I ask about the bond angle, then between equatorial, that means between the equatorial blue bonds, it is 120 degree. And if we have between axial and equatorial, this is equal to 90 degree. All of you got this? Yes or no? Please tell me.
Yes, sir.
Anji, got it? Now, if I look at some examples, then example can be this particular A will be having 5, A is having 5 bonds, so it should have 5 valence electron at least. If it is having 5 valence electron, then in that case, what we can say, it will be phosphorus, nana particle Ashwara that part, group 15. So P, and you can write the B is chlorine, so PCl5 will be there. Okay, we can have PCl5. What else can be there? You can have other things also. You can have PF5 also. You can have another PH5 also. Okay, so all of these things, but example PCl5 is very important. All of you got this? Yes or no? Please tell me. Anji, bataya.
Yes, sir.
All of, okay. Now, formation of PCl5 and the structure of PCl5 is important. So we are going to discuss the structure of PCl5. Structure of PCl5. Achha, before I go to structure of PCl5, you guys tell me, see, these axial bonds are having, they're having bonds on 90 degrees, right? And there are 390 degree bonds, correct? Yes or no? How many 390 degree bonds? How many 90 degree bonds? There are 390 degree bonds, correct? Yes or no?
Yes, sir.
Right? Now, which is nearer, 90 or 120? Which angle is nearer? Like if you talk about repulsion, these angles will be having more repulsion or these angles will be having more repulsion? The white or the white blue? Which one will be having more repulsion? Think about nearness. Which is more near? Is this more
White
near?
blue.
White and which is more
Blue.
near? No. I'm talking about, let me make it like this. Pink and white or white, pink and blue? Pink and white or pink or blue? Which one? Which is near?
Pink and white.
Pink and white are near, right? That is why. Yeah, correct. Arya. That is why I can say that the axial and equatorial bond, this axial one, they will be experiencing more repulsion. Can I say that? Because they are having 3 bonds near to them. Right, guys? Yes or no?
Yes, sir.
Okay, now please see. Structure of PCl5. Now, in this case, I will write first of all, the axial bond of PCl5, the axial bonds, they will be experiencing more repulsion because of the 390-degree bonds that they are having. And because they are experiencing more repulsion, they will be pulled out a bit. That is why the axial bonds will be a bit larger or greater in length. So you write first of all, axial bonds of PCl5 is greater than equatorial bond. Due to, why? Due to the bond pair repulsion at 90 degree. At 90 degree. Due to 3 bond pair repulsion at 90 degree. Got this, Asma? Please tell me.
Yes, sir.
Okay. Then you will write, therefore, the 2 axial bonds of PCl5 are weaker and easy to break. And when you heat PCl5, then what happens? You form PCl3 and Cl2. And these Cl2, they are coming from the axial ones. यहाँ से एक Cl, वहां से एक Cl निकल के, that makes you PCl, that makes you Cl2 and the PCl3 is left. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
Okay. ठीक है, आप इसके बाद एक और नोट भी लिख लीजिए about the axial and equatorial bond. Axial bond experiences 3 bond pair repulsion at 90 degree. ठीक है, next. Equatorial bonds experience, see, this particular one bond, it will experience 190 degree here, the other 90 degree here, right? So it is only experiencing 290 degrees, right? 2 bond pair repulsion at 90 degrees. Okay. Acha, if the axial bond is experiencing more repulsion, if it is experiencing more repulsion, the axial position is experiencing more repulsion. That is why we don't keep lone pair on that. That is not a stable structure. It will not be stable. It will not be beneficial for the molecule to have a lone pair on the axial bond. On the axial position, if you are going to keep a lone pair, so that lone pair will be repelling 3 different bond pairs at 90 degree. So we don't keep it there. Where do we keep the lone pairs? We keep the lone pair at equatorial position, because if I keep the lone pair at equatorial position, it can only repel 2 bond pairs. And we need a least repulsion. Okay. You will write hence, in the presence of lone pair electron in trigonal bipyramidal geometry the lone pair are placed at equatorial position for least possible repulsion and greater stability. All of you understood this? Yes or no? Please tell me.
Yes, sir.
हाँ जी, ठीक है. अब लिखते हैं केस 2. Here we are going to have 4 sigma plus 1 lone pair. This is also again what? It is going to be 4 plus 1, 5. Steric number is still 5, and we will have A, B, 4 surrounding atoms, and there will be 1 lone pair. Now here also the hybridization. Hybridization is still going to be sp3d. And whenever the hybridization is sp3d, the electronic geometry will be same. It will be trigonal bipyramidal. It will be trigonal bipyramidal. Okay. Now let us make the trigonal bipyramidal. So we had the trigonal bipyramidal here. Let me just copy this. So I'm making geometry right now. And tell me, where should I put the lone pair first of all? White में या blue में? कहाँ पे रखे lone pair? Where should I put the lone pair, white or blue? We have just written a note now. Axial or equatorial? Where should I place the lone pair?
Equatorial.
Read the note and tell me, guys. Where should I put the lone pair? Oh my God.
Equatorial.
Equatorial position, no? So blue one, right? Equatorial is blue. Yes, Alia, correct. So I will put the lone pair here, and then I will write B, 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 and B. Now, in this case, if you look at the electronic geometry, is still what? Trigonal bipyramidal, right? We are having electrons in all the trigonal bipyramidal structures, the shape, the geometry. But if I talk about the structure of the molecule or the shape of the molecule, then it will be something like this. Read. You have A like this, and the B's are here. You have seen something like this when you were in your childhood. You must have played with it. What is this? Alia, correct? I want others. I mean, those who are in 11th standard right now. Anji, Yasir, Sara, Siddiqa. What is this? Doesn't strike your brain. Pi mat bol dena bhai koi bhi. It is not pi. Huh?
Slide.
Not right. There is a special name for this, no? Anji. Don't guys, you guys don't remember at all. Yes, Yasir, correct. Sara, Siddiqa, no idea.
I don't remember what it's called.
Siddiqa, do you remember? Martin?
I don't know. I know things.
Oh my God, seesaw, na? This is seesaw, right? Yes or no? Anji, seesaw nahi? Suna hai ki nahi suna? Seesaw. This shape will be seesaw. Got it, guys? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. Now let us talk about some examples. So if I talk about A is having how many valence electron? 1, 2, 3, 4 are taking part in bond. 5 and 6. So 6 means valence electron is 6. That means which group? The group will be 6 valence electron, that means the group will be, अरे बोलो भाई, group कौन सा हो जाएगा? Oh my god, what will be the group? Valence electron is 6. Yeah, so 16, that means sulfur, for example, right? We cannot take oxygen and all, because oxygen, the second period element, they cannot have more than 8 electrons, right? So in this case, you can see we are having 4, this is 8 and 9, 10 electrons in the valence shell. So that is only possible after the second period. That means on third period and onwards, we can have more than 8 electrons because of the presence of 3D sulfur. Okay, but you can write SF4. Anna guys. So what will be the structure of SF4? It will look something like this. Sulfur. Here you will have fluorine, 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 and you can write lone pair electrons like this. Got it? Yes or no? Please tell me.
Yes, sir.
किसी कोई डाउट तो नहीं है? No doubt, right? Yes or no? So, moving on to the next part, that is case 3. Case 3. In case 3, we will be having 3 sigma plus how many lone pairs for steric number 5? How many lone pairs for steric number 5? How many lone pairs will be there for steric number 5? 2 lone pairs, right? Very good. Sorry, not 2 sigma, my bad. 2 lone pairs. Now, if we have steric number 5, then the hybridization is still going to be sp3d, and the electronic geometry will still going to be trigonal bipyramidal. Now we are going to look at the shape. So first of all, I will make the electronic geometry. Electronic geometry is trigonal bipyramidal. So ये आ गया हमारे पास trigonal bipyramidal. हाँ. So this is the electronic geometry. Here are the electrons. Here we have the electrons, and then we have to make what? Now we are going to make the shape. If we are going to make a shape, so हम लोग कहाँ पे रखेंगे? I mean, where are we going to keep the lone pair electrons? I will keep the lone pair electrons on the equatorial position, right? And the B atoms will be like this: B, B, and B. If I talk about the shape, I will ignore the lone pairs, and I will only write B, B, and B. And if you look at this particular shape, क्या नाम दे बताइए? हाँ जी. Sorry, what?
Seesaw.
अरे सीसॉ ऐसा नहीं होता है ना, सीसॉ ऐसे होता है. फर्क नहीं दिख रहा है आपको सीसॉ इसमें? क्या शेप नाम बताइए, क्या शेप देते बताइए? इट इज लाइक दिस ना, सीसॉ तो ऐसे था ना, and it is right like this now. Tell me, this was seesaw, right? And what is the shape? Tell me, what is the shape? It is some letter, right? What letter is this?
T.
T. बस वही नाम है तो उसका T shape. Got it? Yes or no? Please tell me. हाँ जी बताएं.
Yes, sir.
So the electronic geometry is what? Trigonal bipyramidal, but the shape is T shape. All of you got this? Yes or no?
Yes, sir.
Yes, sir.
Study example. Now let's look at the example. So valence electron in A. One, बोलो भाई बोलो, बहुत हम करते हैं, आप लोग बोलिए अभी. Valence electron in A. Number of bonds plus number of lone pair electrons. ऐड करके बताइए what is the number of valence electron here? यार देखिए, किसी को नहीं आ रहा है ना, कोई दिमाग ही नहीं लगाना चाह रहा है यहाँ पे. अरे भाई, पिछले वाले सवाल में हमने किया था ना जैसे, वैसे तो कम से कम ट्राई कीजिए. दिमाग ही नहीं लगाना किसी को, है ना, बस खाली हुई सर बताते जाइए. यस सर, ये सर हम लोग करते जाएंगे. नंबर ऑफ वैलेंस इलेक्ट्रॉन इन ए, फॉर्मूला बता दिया हमने. हाँ जी सारा बोलिए. सारा टेल मी, यू आर सेइंग समथिंग?
No, sir.
नो, कुछ नहीं बोल रही है. थोड़ा तो यार दिमाग लगा लो प्लीज मेरे लिए. Number of bonds plus number of lone pair electrons. Number of bonds plus, yes, Alia correct. Number of bonds कितने बोलो भाई? Siddhika is not replying. Siddhika, are you not in the class or what is there? happening? हाँ, अब्दुल्ला और यासिर तो ऐसे ही रहते हैं. कभी कभार यासिर कुछ रिप्लाई कर दे तो बड़ी बात हो जाती है. Martin replies sometimes. Yes, Sarah, tell me. अरे नंबर ऑफ बॉन्ड्स तो बताओ भाई, इतना चुपचाप क्यों है? नंबर ऑफ बॉन्ड्स कितने हैं ए के पास?
2,
2 बॉन्ड्स.
3.
क्या मतलब, आप क्यों गुस्सा दिलाना चाह रही है? नंबर ऑफ बॉन्ड्स कितने? कीप योर माइक ऑन ना एटलीस्ट. फिर आगे तो हम नहीं
ठीक.
पूछने वाले ऐसे भी, है ना? तो कोई जवाब ही नहीं दे रहा है. एंड हाउ मेनी लोन पेयर इलेक्ट्रॉन्स, सारा?
2.
आई एम आस्किंग वंस अगेन, है ना? दो सही जवाब नहीं. थोड़ा ध्यान सुनिएगा सवाल क्या हम पूछ रहे हैं, ना? Don't look at the lone pair 10 times. Just listen to my question 10 times. Repeat it. Lone pair electrons. I'm not asking lone pairs. I'm asking lone pair electrons कितने? The non-bonded electrons, the electrons which are not taking part in bond formation, वो कितने हैं? In A. Lone pair electrons, not lone pairs. Lone pair electrons कितने हैं? Yes, Sarah.
2.
No. Once again, I said 2 is not the right answer. 2 is not the right answer. I said that. Okay. You are telling me the answer for lone pairs. So we have 2 lone pairs. But how many electrons are there in those lone pairs? Tell me. How many electrons?
4.
4, right? So the valence shell. देखिए, last दफा हम बता रहे हैं, इसके बाद हम बताने वाले नहीं है समझा के. I will just keep on going with the examples. A will have this 1 electron, 2 electron, 3 electrons. 4, 5, 6 and 7. इस तरह से काउंट करते हैं. So it is having how many valence electron? 7. Therefore, the group will be 17. And in group 17, I cannot take fluorine because fluorine cannot make, it cannot have more than 8 electrons. Huh? It cannot have more than 8. Right now, this A is having how much? 6, 7, 8, 9, 10 electrons. It is having. Wait a second. 6 and now 10. It is having 10 electrons right now. Okay. So it cannot have 10 electrons. So fluorine will not have. So what will have? Chlorine can have, right? So you can write chlorine, Cl, F3, Br, F3. All of these are examples of what? All of these are examples of T-shape. All of these are examples of T-shape. You can see this in detail also. Huh? If you want to write chlorine, so in chlorine you will have fluorine, fluorine, and fluorine. So 1, 2, 3 electrons are taking part in bond formation. Remaining electron is 4. 1 lone pair, 2 lone pair, as you can see. Steric number भी 5 हो जाएगा यहाँ पे. ठीक है? All if you done writing this, yes or no, please tell me.
Yes, sir.
Right next. Steric number 6. अब इसके आगे आपके पास क्या हो सकता है? You can also have steric number. I mean, you can have 2 sigma bonds and 2 sigma bond and 1 lone pair. In that case, the geometry will be just linear. You will have. चलिए हम ये भी करा देते हैं आप लोगों को. Case 4. देख लीजिए बस आप लोग. Case 4. In this case, you will have 2 sigma plus 3 lone pair. 2 sigma plus 3 lone pair electrons. Now, hybridization is still going to be sp3d, and the electronic geometry still trigonal bipyramidal. And if I look at the shape, then the shape will be. So we'll put the lone pairs first of all. So we have 3 lone pairs. So 3 lone pairs will be on the equatorial position because of less repulsion. And I will put the B atom here and another B atom here. Now the B atoms are here. So if I make B, A, and B, so this is kind of what? Straight line. So the structure or the shape will be linear. Shape will be linear in this case. If you want to also write about the A, so the A will belong to which particular group? So A is having 1 and 2, 3, 4, 5, 6, 7, 8 electrons. So it is having how many electrons? It is having 8 electrons. 8 electrons in the valence shell. That means which is the group number? The group number is 18. In group 18, there we have only one element which is able to form bond, and that is X. Xenon. Xenon, and obviously B is going to be a monovalent. So I think you can write XeF2 can be a molecule which is going to follow this particular shape and the geometry. Okay, write this down. XeF2 is an example here. Anyone still writing?
No, sir.
Right, next, steric number 6. ठीक है, steric number 6. अब यहाँ पे आपके पास, I hope you can understand the number of cases we can have. ठीक है, थोड़ा सा यहाँ पे ध्यान से हम लोग देखते हैं. पहले सबसे पहले केस 1 देख लेते हैं. Case 1. Here we'll be having 6 sigma plus 0 lone pair. 6 sigma plus 0 lone pair. And the hybridization in the steric number 6 case, it is equal to sp3d2. The atomic orbitals which will be taking part in this particular hybridization will be S. Then you will have px, py, and pz. Then you will have the 2 orbitals from the d subshell. And when we are going to mix all of them, we will get the hybrid orbital, and we will get 6 sp3d2 hybrid orbitals. And when you are going to arrange them, then it will look something like this. A, है ना? तो अगर आपको थोड़ा सा, I mean, if you want to understand it in a better way, then you can understand it like this. We have, please don't write this sphere and everything, okay? So we have sphere something like this. Push this middle में आ गया, है ना? Now, obviously, you can have one atom here, the other will be here, the other will be here, 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 and here. Okay. So obviously, this is going behind the plane. This is coming in front of the plane. This is going behind. This is going behind. This is coming in front of the plane. Okay. And this 2 are on the plane. So essentially, I can write it like this. Okay. Now, please listen. I mean, when I write this in all straight lines, it does not mean all of them are in the same plane. And you have to understand that these are going behind. This is also going behind. This is coming out of the plane. This is coming out of the plane, but we don't show it in such detail always. So we are going to write it like this. So here you are going to have the 6 electronic geometry. I mean, 6 electron pairs. The bonded pairs will be here, and I can write it as AB6. So you'll be having the B atoms here. Now, all of these are equivalent. There is no difference in all of them. Okay, all of these are completely same. And the electronic geometry here, it is known as octahedral. आप बोलिएगा सर यहाँ तो 6 ही है, octa कहाँ से आ गया? So octahedral, it becomes octahedral when you are going to join these particular points. Okay, so if you join these points, it will make an 8-phased structure. अगर आपको दिखे थोड़ा सा, कोशिश कीजिएगा. So this is one. Yes or no? Please tell me. One face. Correct, guys?
Yes, sir.
हाँ जी बताइए. Then now you tell me. Take this blue one. Backside you can have a face, right? Yes or no? Now take this pink one. Now pink is having a face. Yes or no? And then you can have these green ones in the front also. So 8 faces on the top and 8 faces will be on the bottom. Total of 8 faces, and hedra means face. Okay, please remember. Hedra means what? Hedra means face. So octahedral. Not octahedral. My bad. It will be octahedral electronic geometry. Electronic geometry is octahedral because it is having how many faces? It is having 8 faces. Electronic geometry. And similarly, the shape for this case will also be equal to how much? It will also be octahedral. And the bond angle in this case will be equal to 90 degree. All of these are 90 degree apart. So from here to here 90 degree, here to here 90 degree. All of these are 90 degree, 90 degree, and 90 degree. Okay. So we have only one type of bond angle. There is no difference. सही है. Now हम पूछेंगे भी नहीं. Valency of A will be 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, and 6 electrons, right? So valency of A is equal to 6. That means group number will be equal to 16,
16.
and the examples can be sulfur with 6 fluorine atoms and SF6. This is an important. SF6 is an example that is should be there. Okay. Now we are going to look at this particular geometry, and we are going to just put lone pair electrons. Okay, we are just going to put up lone pair electrons and understand the rest of the shapes here, and then we will write the examples also. All of you done? Yes or no? Please tell me.
Yes, sir.
Now please see. Next case we are going to write in the cases. So I will have, let us suppose now we are having how many sigma? 6 sigma. No? So we will be having 5 sigma plus 1 lone pair. 5 sigma plus 1 lone pair electron. Okay. Now the electronic geometry is going to be the same, but there will be reduction in the one of the
Sir?
bonds. Tell me.
Just case 2.
केस तो ऐसा लिखनी है नहीं. अब तो इतनी दफा हम लोगों ने केस लिख लिया कि डायरेक्टली आप यहाँ पे लिख सकते हैं. ठीक है. So don't write. I mean, if you want to write in detail, you can write it in detail, but it's going to take a lot of time. We have been doing this for so many times that we can understand. This is case 2. 5 sigma plus 1 lone pair. The steric number is still 6. Now, since all of these bonds are same, I can remove any one of the bonds and put up the lone pair here. This is my lone pair. And now, if you look at the structure, you just look at the shape here. The shape is something like this. We have 4 B atoms and 1 B atom here. So we can make a square and pyramidal. Yes or no? Please tell me, guys. Correct? Hai?
Yes, sir.
Correct? Na? So this is what still octahedral. Electronic geometry is octahedral. And the shape will become what? Shape is going to be square pyramidal. Correct? Shape is going to be square pyramidal. Now, next, if you look at the example, so A will be having 1, 2, 3, 4, 5 electrons, 6 and 7. So 7 means group 17. In group 17, you can have chlorine or bromine, something like that. Examples can be chlorine F5 is very unstable because chlorine is relatively smaller in size and it cannot have 5 fluorine atoms around it. So bromine is the next atom which is a bit larger. It can have, for example, अगर आप chlorine लीजिएगा इतना बड़ा और fluorine आपके पास अगर मान लीजिए, it is smaller than chlorine, but still it is something like this. So you cannot have 5 fluorines around it. It is not able to hold 5 fluorine. So example would be Br5, BrF5. Another example could be iodine F5. Okay, so all of these are examples of what? 5 sigma and 1 lone pair electron. All of you got this? Yes or no? Please tell me. किसी को कोई दिक्कत?
Yes, sir.
No, right? Let me just decrease the size of these two. Next, we are going to have another case in which we will be having 4 sigma, and I will be having 1 lone pair electron. Sorry, 2 lone pair electron. That will be, so my bad, 2 lone pair. That means it is state number 6. 2 lone pair. The electronic geometry will be still octahedral, but the placement of lone pair you can see something like this. एक बार हमने नीचे रखा था, एक बार ऊपर रख देते हैं, है ना? So it is still what? The geometry is still octahedral. Please understand that. So where do we have the electrons? We have the electrons in octahedral geometry. But the shape is going to be B atom, B atom, B atom, and B atom are here. So it is almost going to make a square. And it is in one plane. So we write it what? Square planar. Understood this? Yes or no? Please tell me. So rather, I mean, this is the actual shape. ऐसे shape बनाइएगा, ठीक है ना? आप ऐसा मत, इसको भी ऐसे मत बना दीजिएगा आप लोग. I am talking how do we name the shape. Shape का नाम कहाँ से आता है वो हम बता रहे थे यहाँ पे, ठीक है? Shape को ऐसे बनाइएगा आप लोग. The bonds. I was talking how we name the shape. So this is square planar, and in this case, if I talk about the number of valence electrons, so 1, 2, 3, 4 in the bond pair, 5, 6, 7, 8. So 8 valence electrons means group number will be 18. Group 18, the example can only be for xenon, and xenon will have, you can have XeF4 as an example. You can also have Xe. O2F2 can be an example. No, I don't think so. XeF4. All of you got this? Yes or no? Please tell me.
Yes, sir.
Anyone still writing? Please let me know. Anyone still writing? No. All of you understood this? Yes or no? Please tell me.
Yes, yes, sir.
ठीक है ना? चलिए. तो थोड़ा सा एक बार इसको फिर से देख लीजिए किस तरह से हम यहाँ पे we are going to make these things. And is there anything that we need to do more here? और तो कुछ नहीं है. तो let us start to summarize these part. Okay. So we'll summarize in the case of steric numbers. Steric number. ठीक है, क्या करेंगे? We'll start with steric number. Then after that, we will write the electronic geometry. Okay. After that, we are going to write the lone pair electrons, na? Because lone pair is something that is going to disturb the shape. So electronic geometry, and then you will write the shape. And then we are going to write the examples. Okay. So I will start with steric number 2. Obviously, electronic geometry is linear. In this case, you can have only 0 lone pair, and the shape is still linear. Now, steric number is 2. That means the outermost electron, the valence electrons, there will be how many valence electrons? There will be 2 ना. तो आपके पास होगा कितना हो जाएगा? BeCl2 can be an example. BeF2 can be an example, right? All of BeF2, beryllium fluoride, all of these can be an example. अच्छा, इसमें एक और काम कर लीजिए अगर आप लोगों को थोड़ी सी दिक्कत हो रही है ना. सिर्फ लोन पेयर में आपको शायद समझ में ना आए तो हम लोग यहाँ पे सिग्मा बॉन्ड भी लिख देते हैं. ठीक है, नंबर ऑफ सिग्मा बॉन्ड्स. सो वी हैव 1 sigma, 2 sigma bonds here. ठीक है, आई थिंक नॉट विल बी वेरी मच क्लियर फॉर ऑल ऑफ यू गाइस. किसी ने अगर लिख दिया था तो उसको इरेज करके दोबारा लिख लीजिए स्टेरिक नंबर. अदरवाइज प्लीज लिसन, you will write it later on. Okay, listen to this completely and then you will write it. After that, we are going to move to steric number 3. इसमें एक और चीज मिस हो गया. थोड़ा चीज मिस होते जाएंगे तो इसको हम लोग ऐड करते जाएंगे ना स्पेस की जगह. I mean, we have not written the hybridization here. If it is important to write the hybridization also, sigma and lone pair can take a bit less space. Electronic geometry and steric number decides the hybridization. So, and hybridization decides the electronic geometry. So I write the hybridization here. In the case of state number 2, the hybridization is going to be SP. In the case of 3, it will be SP2. The electronic geometry is going to be trigonal planar. The sigma bonds, the number of sigma bond, it is going to be how much? It is going to be 3 and 0 lone pair. So the shape is also going to be the same, trigonal planar. The examples here in this case are what? We have seen an example for SP2, which was BCl3, BF3, BCl3, right? All of these are examples for steric number 3 with hybridization SP2 and 3 sigma bond, 0 lone pair. There can be another case in which we are having 2 sigma bond and 1 lone pair. In this case, what is going to happen? The trigonal planar is like this. You remove one of the bond. You're going to remove one of the bonds. Huh? You're going to remove one of the bonds. You will get a bent structure. You're going to get a bent structure. So write bent. Okay. An example in this case will be O3 molecule is an example. Okay, ozone. After that, we are going to move to 4, which will be sp3. And the electronic geometry in this case is tetrahedral. Sigma bond 4, lone pair 0. And the shape in this case will be also tetrahedral. And we write TD as short for tetrahedral. Okay, TD is short for tetrahedral. Examples are CH4 is a good example. CH4. And if you have carbon with 4 single bonds, any carbon with 4 single bonds, it is going to have what? It is going to have the same hybridization. Right? After that, in the same hybridization, sp3 tetrahedral, if we are having 3 sigma bond and 1 lone pair, then the shape becomes trigonal pyramidal. And we have seen the case of NH3. Next case can be if you are having 2 sigma and 2 lone pair, then the shape becomes bent. And an example is water molecule. याद आ रहा नहीं याद आ रहा सबको? हाँ या ना बताएं.
Yes, sir.
sp3d in the 5 steric number, and the electronic geometry is trigonal bipyramidal TBP. First case, we are going to take 5 sigma 0 lone pair. The shape is still going to be the same, TBP. Example will be PF5, PCl5. Both of these are example of TBP. Next, we can have, you reduce this one by 1, 4 and 1. If you reduce by 4 and 1, you will get seesaw. Example, we have seen SF4. Okay. Next, we are going to reduce it furthermore, 3 and 2. The shape becomes T-shape. Shape becomes T-shape. Now, try to move from trigonal bipyramidal, seesaw and T-shapes logically. Okay. So, रटने की जरूरत आपको नहीं है. Okay, you have to make it and then understand it properly. You will do it 2 times, 3 times. You make the TBP and then make seesaw and then make T-shape. Then only you are going to understand it, and then only you are going to be able to remember it, not memorize. Okay, don't sit with it and like this, and you are going to memorize. Don't memorize it like that. Okay, T-shape. How are we going to calculate what? Let us calculate the valence shell. For valence shell, we have 3 and 4. So 4 plus 3 is 7. So 7. That means you can have Cl F3. You can have Br F3. Okay. You can have another case in which you are going to have 2 sigma and how many lone pairs? 3 lone pairs. And in this case, you will get linear. जब भी आपके पास 2 sigma आ जाए ना, तो आपको यहाँ पे generally you will see no, you can't summarize it like this, that it will be linear because it will be bent also sometimes. Huh? So 2 sigma and 3 lone pair will be linear in this case. And the example was XeF2. Xenon fluoride. Now moving on to the last case, 6, which is sp3 d2. The electronic geometry here is octahedral. And first of all, I will take 6 and 0. The shape is also octahedral. An example was SF6. Moving, we will have 5, 1. It will be square pyramidal. The example in this case was BRF5. Okay. BRF5. After that, we are going to have 5 के बाद कितना हो जाएगा 4 and 2. This was square planar. And we had an example of what? XCF4, I guess.
Yes, sir.
XCF4, right? Did we have anything else? No, don't need anything else after this. Okay. Then here you have right. All of you done? Yes or no, please tell me.
Yes, sir.
Okay. So, I mean, you guys are going to get like 5 more days, right? 5 days without my class. So you're going to write each and every one and try to explain it yourself, how it is bent, how it is tetrahedral. I mean, this movement is very, very crucial. How you go from trigonal planar to bent, how you explain this. Tetrahedral to pyramidal, pyramidal to bent. Okay. Then TBP to seesaw, seesaw, and from then TBP to T-shape, TBP to linear, octahedral to square pyramidal, octahedral to square planar. Okay, so this transition is very important. How you are going to explain and how you understand that, okay, fine, it is going to be seesaw. You don't have to memorize it. And you guys only said, na, T-shape. Tell me, Sarah, Alia,
Yes, sir.
all of you. You guys only recognize, na, it is seesaw. Correct? Yes or no?
Yes.
Anna? So it is not something that you have to memorize. You just try to understand. Okay, you just try to understand. Even for the case of square pyramidal, if I have, then what did I told you guys? You will have A, the B are here like this. Then you just remove the bonds and just take the B as points. Okay, so if you are taking B as points, it will give you a pyramid. Anna? It's going to give you a pyramid. This base is what? Square base, and it is a pyramid. So it will be square pyramidal. Okay, so try to make yourself understand these things. It may seem like memorization right now, but when you are going to, like how I am making the shapes now, you try to make it like that, and then you will understand and it will be there in your head for a longer time. Is this clear? Yes or no? Please tell me.
Yes, sir.
There is one question that I will do, and then I will end this class. There are 2 questions like this. Okay, so both can be explained in a similar way. .25 and 4.26 in the NCERT. Please see this question. Don't write anything. Describe the change in hybridization, if any, of aluminium atom in the following reaction. If I look at aluminium in this case, so it is aluminium, and it is having 3 chlorines, right? So I don't know about the shape and all that. So I will just write aluminium and 3 chlorines like this. This is just my Lewis dot structure. Now, aluminium, it has how many valence electron? It has 3 valence electron, and all of the 3 valence electron are consumed in the bond formation. It is having no lone pair electrons. So sigma bond, it is equal to 3, and lone pair, it is equal to how much? 0, guys. Yes or no? Please tell me.
Yes, sir.
Bolo. 3, sigma is 3, lone pair is 0. The steric number will be 3.
3.
So the hybridization क्या हो जाएगा 3 के लिए?
SP2.
SP2. Very good. Now we are having another case in which we are having AlCl4 negative. So now aluminium is bonded to 4 chlorines. So how many sigma?
4.
4. And still it is not having any lone pair. The lone pair is 0. The steric number will become
4.
4. Hybridization will become SP.
SP3.
That is the change in hybridization. Got this, guys? Yes or no, please tell.
Yes, sir.
ठीक है, चलिए अब उसके बाद यहीं पे दूसरा जो है इसको भी देख लेते हैं. ठीक है. Is there any change in the hybridization of boron and nitrogen as a result of the following reaction? Okay, as a result of following reaction. Now, what is the reaction that is taking place here? Please see. We are having boron, right? And we are having F3. Okay. If you look at boron, boron has the valency of how much? Hydrogen, helium, lithium, beryllium, boron. 5. So 1s2, 2s2, 2p, 1. In excited state, it will be 2s1 and 2p1. Now, in boron, what actually is happening? We are having in boron, you will have 2s and you will have 2p, 1, 2, and 3. Now, these are having electrons, but this p is vacant, right? This p is vacant, completely vacant p orbital. And also, if you look at boron, it is having only how many electrons? 1, 2, and 3 electrons. That means 3 bonds, that means 6 electrons. This is having only 6 electrons. That means it is what? Electron deficient. And it also has what? Pure p orbital, which is completely vacant. This is the p orbital, which is vacant. P orbital, which is vacant. Now let us look at NH3. NH3, it is having 3 hydrogens. And it will be having a lone pair electron also, right? Because it is having valency how much? Valence electron is 5. 3 of them are bonding, 1 is lone pair. So what actually happened here is this lone pair electron is given to the vacant shell of the boron. Okay, and reaction happens something like this. Please see. We have H3 nitrogen with its lone pair electron, and then we are going to have. अच्छे से दिखा देंगे आप? चलिए अच्छे से दिखा देते हैं आप लोगों को. बिल्कुल सब चीज के साथ nitrogen with its trigonal pyramidal structure of NH3 and a lone pair electron here. And if I talk about boron, so boron will be having something like this trigonal planar structure, and there is a lone pair, there is a vacant p orbital which is like this. Vacant p orbital which is like this. Now this lone pair electron is given to boron, making a coordinate bond, and this results in the formation of nitrogen, which was having 3 bonds. Now it has another 4th bond with a boron atom, and this hydrogen are as it is, and the fluorine are as it is. Now let us look at the change. Let us look at the change. If I talk about nitrogen in this case, it is having 3 sigma plus 1 lone pair. That means the steric number for this is, for nitrogen, the steric number is equal to 4, and the hybridization will be equal to sp3. If I talk about the boron atom, it is having only 3 sigma bonds and 0 lone pair electrons. Steric number here, it is equal to how much? 3, and the hybridization will be equal to sp2. But now in this case, both nitrogen and boron, they are having 4 sigma bond plus 0 lone pair, है ना? तो दोनों के लिए steric number कितना हो जाएगा? दोनों के लिए steric number हो जाएगा 4, and the hybridization will be equal to sp3. So obviously, nitrogen is not doing any change under the hybridization. It was sp3. It is sp3. But yes, boron, it was sp2, but now it is sp3. All of you got this? Yes or no, please tell me.
Yes, sir.
Okay. So this is a coordinate bond. And we write coordinate covalent bond because obviously sharing of electron is taking place. Coordinate covalent bond. इनको screenshot ले लीजिए आप. Take a screenshot for this, and then you will open up the Learnivio app to give the test.
There will be a topic VSEPR theory.